Problem 4-123. Replace the force and coupling system on the frame. So we got two forces and one moment. By an equivalent force, and specify where it might intersect the line BC as measured from B. So we want to take both these forces, add them together, and put one force somewhere on this to create the equivalent moment. So let's start by breaking down these forces. So here we got a 150 force. I'm going to draw right here. 150. And that's a 3, 4, 5 triangle. So 150, divide 150 by 5, you get 30. So this would be 120, and this would be 90. Okay, and then we have this 50-pound force at a 30-degree angle. So let's draw this over here. And so this angle here is 30. So this is 50 cosine 30 and 50 sine 30. And 50 cosine 30 would be 43, and this would be 25. All right, let's sum the forces in the x direction. That's going to be 120 plus 25. That equals 145. Sum the forces in the y. We get 90 and 43. And that equals 133. And we'll sum the moments about, go ahead and sum about A. Yeah. So if we have the 90 goes up through A, 120 there, so 120 times 2 will cause a positive rotation. So 120 times 2. And then this one we have the 25 and we have the 43. They both cause rotation. So 25 will cause rotation in positive direction, plus 25. So the 25 goes this way, and we have a moment arm of 6. And then the 43 causes a negative rotation that way. And so we're going to do minus 43 times 3. And then we have a positive 500. So the moment about A is 761. Okay. Now where do we place this load? So we have a load of 145 in the x, 133 in the y, and we want to put it here somewhere, a distance from B. We'll call that distance x. Okay. And we know that's going to create a moment about A of 761. Now, rather than just saying moments about A, I probably could have solved about B. Might have been a little more convenient, but we'll keep making this work. So the moment about A is equal to force in the x direction, so the x component, times 6. And that's going to cause positive rotation. And then negative rotation by force in the y direction times x. So MA is 761, Fx is 145, and Fy is 133x. So solving this, x equals 0.84 feet from B.